My name is Rami Yaron. I'm chairing the Marketing and Education Committee, and I'm also chairing the 5G focus group at the MEF, and I'm a strategic advisor for Infovista. I'm here with Sibylle. Sibylle is the editor of the network slicing work that we are doing at MEF, and she's also project manager at NEC Lab. And what we are discussing today is what the MEF is doing with 5G. A lot on orchestration. So this is mainly the project that MEF is working on. If you want to hear more about 5G, we have a session on Wednesday afternoon. This session is more about the work of MEF with 5G and also orchestration of 5G services using LSO. So let me start. So we are starting with the introduction, a little bit on the 5G features, what we are doing with 5G, and then the project. So the first project that I'll cover is transport for 5G, how MEF is supporting the 5G transport, the signal from the base station to the core. Then we'll talk about orchestrating 5G services. And after that, Sibylle will continue covering 5G network slicing, which MEF is doing a lot of work with that, and also MEF services over 5G slices. That's the summary of the MEF work. So let me start. I put here this slide deck just to get an idea on what is 5G. To me, 5G is much more than just another generation. We have a lot more features than we had before. We are talking about more bandwidth, more capacity, low delay, and a lot of new devices that are getting connected. Some of them are in industry that were not connected to mobile at all in the past. And a lot of miniature devices, things like IoT that are going to get and already are in the network. So this is just to show you, to me, it's a disruptor. It's much more than just another generation. This slide just shows you the technical specification, just a peek on what we have with 5G. So obviously we are talking a very high data rate peak. So we have a lot of capacity. Spectrum efficiency is much, much higher with 5G. Latency can be very, very low, and lots of devices can be connected. We are also talking about much more reliable network if needed, better availability than before. We are talking about devices that, very small devices with battery that can last for, let's say, 10 years. So this is just to show you some of the different attributes. One thing that is very strong with 5G that we didn't have before is the security. Now there is a few levels of security, which is much better with, than in 4G. So if we are talking about the generation, there is a lot of cost involved with it. Operators need to fund the way that they are deploying the new radios, the new RAN, the core, and therefore they need more use case for businesses, more businesses, and this is what 5G brings. So one of the things, if you look at, I don't know if I have a pointer here, yeah, I don't think the pointer works. So if you look at the bottom, we have the enhanced mobile broadband. This is, everybody is used to that. We have it on our devices, we have it on our computer, tablets, With 5G, we'll get much more. So this is more or less the consumer business and a little bit more than that, but we are looking at other verticals that are more machine-type communication. We are talking about high density. This is the IoT, the small devices, connected car, all of that. We are talking about low cost, low energy devices, lots of them that will be connected to our network. And then we have the ultra reliable low latency network. This is for critical communication, a very reliable network that also provide very low latency. Those last two are more machine type communication. So those are new industries that were not connected to mobile before, things like manufacturing. So all of that is a new business that 5G brings. When you look at the MEF focus, there are a few things that we are doing. First, how MEF services can support 5G. This is the transport, the communication from the cell site to the core, how MEF can help getting it better. And the other thing is MEF services over 5G. So 5G with the low latency, the high bandwidth, we are actually looking at ability to run MEF services on top of it. And the last thing is network slicing that apply both for the transport and for the service end-to-end. That's the MEF focus. So let's start with the transport. So this is a summary of what we did with the previous work with the 4G. We define basically the backhaul in 4G, the backhaul from the cell site to the core, how we backhaul the traffic. This is an ongoing work that we started in generation 2 and cover it up to 4G. In 4G, we also cover what we call middle. This is the work of the transport between the cell site and the small cell. So if you have a small cell, you want to aggregate it to a cell site, you may need different requirement for the transport just between the small cell and the macro cell. So at the time, we call it mid-haul, and this work is also part of MEF 22. What happened with 5G, people start asking us also to focus on front haul. This is where you actually split the radio into two pieces and you need a high bandwidth, low latency between them. So now with MEF 22, we are focusing on front haul as well. And this is what I'm going to discuss. So if we look at the 5G transport, we have the radio head, and we have the core. And if you see on the, my left side, we can take the radio and split it in order to get more efficiency. Why do I need to split the radio? If I have spectrum and the spectrum is finite, I want to reuse it as much as I can. And if I reuse it, I may have interference. I want to coordinate between the different radios. It's much easier if they are close together. So if I split the radio head from the digital unit, put the digital unit together, I can actually do better coordination. That's one reason. The idea is basically to provide different architecture based on the availability of transport, the need for the coverage, and a few other considerations. So in the bottom, you can see different topologies of basically depend on the split and the availability. If I want to have something like called Cloud Run, when all the BBU, all the digital unit, they are in one location in the cloud, and there is a high bandwidth fiber between them and the remote radio, or any other way that I want to do it. So there are many different architecture that we can use, and MEF is trying to cover them with the specification for the transport. By the way, when we are doing the split, there are a few ways to do it. The more you do the split closer to the radio, the more efficiency you're getting, but your requirements are much higher for the transport. The more you do the split further from the radio, it's much easier to do. The requirements for the transport are lower, but also the efficiency are not getting much as before. So 3GPP agreed on basically 2 split, 1 cross and 1 far. So we have the options. So if we look at the transport, we are talking about the D run and the C run, the distributed run. When I have the radio, I have the 1 split, so I have front haul and back haul. And I have the C run. The D run is more distributed. When I have a venue I need to cover and I have 1 split, I have many antennas. And in one place in that venue, I put all the base stations. With C run, I put the base station in the cloud, in data center, let's say, and from there have fiber to the remote radio head. And you can see the different requirements. The requirements for the front haul are more or less the same. It's just the distance is much longer with the cloud, with the C run. And then we have in the 2 buttons, we have the 2 splits. So I have the remote radio head, the DU and the CU. And MEF also covered the specification for that, whether you are doing it or you are doing the virtual run. With virtual run, actually, you can virtualize your run if you have compute. And now you have to worry more also about the VNF and the compute and all of that. We'll talk about it when we talk about orchestrating 5G services. So we have requirement for all the different architecture. So we are covering in MEF 22 today, we are covering front haul. We already covered back haul. So we are having the requirement for the different split. This is work that should be completed this year in MEF 22. One last thing, I'm not going to cover network slicing. Sibylle is going to cover it. The only thing I would like to say about it is that everybody talk about network slicing on the mobile side. In order to have end-to-end services, the transport need to support the requirement of the network slicing. So transport and mobile need to coordinate much better today than before. And if you want to hear more about that, Sibylle will talk about it, and we'll have a session on the Wednesday afternoon that also discuss it. So as I said, orchestrating the transport, if we want to have dynamic network slicing, if we want to have good transport, we need to coordinate with the RAN domain, with the orchestration of the mobile in order to get more dynamic and better transport. And this can be done also with LSO. So what these pictures show, the mobile domain is basically managing the RRH, the DU, the CU, and the LSO manage the transport, whether it's the front haul or the back haul. The other thing I want to discuss a little bit is how we are going to orchestrate 5G services. So why we want to do that? Fiber is not available everywhere. We want to run over 5G if 5G is available. We see more and more devices with LTE antenna. We'll see more and more in 5G. You see that SD-WAN is now going. One of the transport is basically mobile. So all of that is why we would like to have also services over 5G. When we are talking about management of these services, we are basically using LSO to manage the service. It can be over one operator, mobile operator, end-to-end. It can be between two operators, so only the access, maybe 5G, and the core is still wireline. And if we have two orchestration framework, we need to connect them with Sonata, with Interlude, in order to make sure that we have end-to-end services. So this is another thing that is very important to support in order to have end-to-end user experience. Okay, let Sibylle continue.
Thank you, Rami. So, yeah, I will continue. So, network slicing. So, network slicing really as a term became a hype over the last couple of years. I think it popped up when NGMN and 3GPP picked up that for mobile networks specifically, but the vision is much, much bigger. And so why do network slicing? So this picture that you see here shows you two extreme examples. The one on the right-hand side is that you have one big network, one infrastructure that you use for all your services. This has advantages and disadvantages. The problem probably is that the services having different requirements to the service parameters, the quality of the data transmission, reliability, bandwidth, we heard it from Rami. It may be difficult to handle over a single infrastructure. A solution for that could be, shown in the middle, to have infrastructure specific per type of service. So now you are able to really serve the services or the application specifically because your network, the hardware, the infrastructure is dedicated and specialized to that use case. This obviously has a big disadvantage. You need to run a couple of different dedicated networks, so you have more than one infrastructure. The idea with network slicing is to combine those two extreme approaches to get the best out of both, but still be flexible with how you use your infrastructure. 3GPP, you probably know this picture from 3GPP and NGMN related publications. Says, okay, we we slice our infrastructure and the resources into so-called network slices. For mobile networks, those consist of RAN, transport, and core sub-network slices, so they have components. So to cover the 3GPP end-to-end. Slices can support different types of networks. So here examples are given for a smartphone slice or autonomous driving or massive IoT. So there are different combinations that already the vision and the current work that you probably have seen goes. You can have one slice per type of traffic, or you can also have 5 types of the, 5 slides of the same type of slice type for the same type of traffic, but maybe for different customers or different purposes. So what it gives operators or network providers is a means to very flexibly and hopefully dynamically to adjust to what is needed by the customers. You probably saw this in one of the previous presentations. So if a provider, an operator decides to slice its network to create slices, then the services, the applications need to be mapped into it. And here this example goes for the SD-WAN. So for example, the UCS1 and UCS2 could be realized with 2 different network slices for different types of connectivity needed here. Now we come to MEF services over 5G network slices. So far, that was more the general for understanding what slicing is about. And now we try to get it more onto the MEF, what MEF is doing. The picture here, you see the 5G service provider network that is, you can imagine, is like a 3GPP operator would possibly structure its network, so it would use network slices, as you know, as you all have read. And then on the right-hand side to it, this service provider network that could be another operator having a 3GPP or not 3GPP network that wants to cooperate with a mobile network operator, for example, to provide end-to-end services, where the end-to-end maybe just the 3GPP mobile network or even going beyond it. So connecting, realizing 3GPP communication service with LSO orchestration, or using a network slice provided by a 3GPP operator as a component, as an infrastructure component for the service provider's network. Here, different options are possible. 3GPP defines also that network slices, their network slices can be network operator internal, so they are just there for the operator's own purposes, or network slices can be exposed to customers in MEF terms, so that would be the verticals, for example, automotive, manufacturing, all these kind of things could be other customers, and their slices or aspects of the slices needs to be made visible. Let me move forward to this slide. Here, this gives a bit of feedback of what we are discussing in the slicing project. We still don't have a publication, so we are targeting to come out more, to still discussing, and it's not so easy to figure out where MEF and the slicing stands, because MEF, as you heard in the first presentation, is not about defining the internal details. So the internal details, for example, could be 3GPP specifications defining how slices need to be done, managed, how the different 3GPP functions need to handle the slicing. MEF rather should look on the customer perspective, the outside. But here, I would argue, still you need to know a little bit about what the inside is so you can talk about it. What we found in the slicing project is, I think that's probably also very general, is network slicing is a means to structure and organize infrastructure and the management to provide flexible solutions for different market scenarios. So this is, you probably recognize, is not the definition that you see from 3GPP, but MEF is not differing. This is, by the way, not the MEF terminology. The MEF definition for network slice, this is not yet published, so we still have a couple of discussions to go on there. So as I said already, network slices can be used provider internally, then of the slice, nothing would be visible outside to a customer. So from the information about the network slice would stay within the service provider's domain. As soon as a service provider decides to expose the slice or give customers options to use what's called a slice, then some information needs to be provided to the customer. And there, a range of options are possible from, for example, just an idea, just the knowledge there is a slice or a network, that would probably what would be exposed. So the information, there is a network, and the customer may choose, okay, I want to have my video application, my video service running over the high quality network because I'm watching it on a big screen. And another time he may say, well, but I'm fine with a best effort network because I'm anyway just having a small screen, for example. This is just a very simple example. And what this picture also shows is that services, MEF services, will be instantiated in network slices. Currently, the LSO, you only see one infrastructure, Slicing gives the service provider to create several such infrastructures, to create several networks, where each network slice may be managed by its own control, management, and service orchestration functionality. So the vertical grouping that you see is giving a hint that not only the infrastructure, the resources are sliced, but for flexible dynamic handling, you also need to, at least logically, slice the management, control, and orchestration. And also to isolate how those different networks can be handled. Services provided via network slice, once it's exposed, you run into the issue that you can say, okay, but now I have a network slice as a service, or a network as a service. And that is where discussions start to get difficult, because then it depends from which point of view you start to look at it. So a provider providing a network as a service, that's a service. But for the customer who may see the network, it's a network. So things start complicated, and this is also what we really see in our discussions. Once talking about service, so to know about services, to communicate about services, to know what can be realized as a service, normally catalogs are being used. Here a few examples are given for potential types of slices, network slices that could be offered. Once a customer orders, for example, a service, or says, I want to have a network of this type, or I want to run my service in this kind of network, then provider internally, there is information how to create the slice, what resources need to be combined to realize it. And on the right-hand side, you just see there can many different things in parallel. You even can have, let's say, 5 robotics communication slices in parallel. They can look identical from the inside, or they can look very different. So there's lots of different options and many things possible that is still not easy to understand. And with that, I want to come to the summary. MEF and 5G. MEF is covering a couple of areas related to the 5G networks, the 5G ecosystem. The dark blue ones are the ones that MEF currently is focusing on its work. And 5G as a vision brings new use cases and business opportunities. As I said, 5G is not only limited to mobile networks, it's much wider, so you will see much more. The discussion currently is very focused on mobile networks, but it's bigger. Multiple transport options could support 5G interfaces. This leads to what Rami was pointing at. So you saw it, especially in the RAN network, there are different options how to structure the RAN network. And here MEF services and also slices, if a transport provider deploys network slicing for its transport network and, for example, offers a transport network slice to a 3GPP mobile operator, there are a lot of different things can be possible that are not in previous releases or versions of the technology. Yeah, LSO can facilitate orchestration of all kinds of networks, so mobile, fixed, and enterprise probably not, but I still would claim that enterprises might, especially if they have bigger networks, they might be interested also to apply something of the LSO. And yeah, network slicing, I don't need to repeat. It offers a lot of new possibilities to adjust or to better serve different applications. And MEF services could run fully or partially over 5G.